All right, in this video, we're going to take a look at this green solid here, the bottom of the page. This is copper 1 bromide. We're going to take a look at if we can find the KSP value for this substance. So every substance has a certain KSP value. So what's the KSP value for copper bromide? Well, the first thing that would help us is if we could write out the balanced reaction or the balanced solution reaction for copper 1 bromide. So we've got copper 1 bromide, which is a solid, and that reacts to form the copper 1 ion plus the bromine ion, right? So this is our balanced solution equation. So the second thing we need to do is write out the KSP equation. So KSP is going to be equal to the copper concentration of the copper ion times the concentration of the bromine ion. And we're not going to include copper bromide in the KSP equation because remember, it's a solid and solids aren't included in the KSP equation. So here's our KSP equation, and we need to find KSP. So what we know about it is that it dissolves to form a solution of 2.0 times 10 to the negative 4th molar. Okay? So imagine if I have 10 of these, it'll break down to form 10 of these and 10 of these, right? So if I know that this forms at has a solubility of 2 times 10 to the negative 4, that means that when it breaks down, it'll form that many of this ion and that many of this ion. So I know the concentrations, therefore, of both of these ions. So all I have to do now is do KSP now is equal to 2 times 10 to the negative 4, and that's molar, right, times the concentration of the bromine, which is also 2 times 10 to the negative 4. And I do that, and I get a KSP value for copper bromide of 4 times 10 to the negative 8. Okay? So the next kind of problem is actually the reverse situation of the one we did in the first slide. So here we're given the KSP value, and we're told to work backwards to find the solubility. So if you actually remember in the last problem, they gave us the solubility of the salt and told us to find and asked us to find the KSP. And here they're asking us to find the solubility of the salt. Sodium iodide is actually a pretty interesting compound. I just wanted to share this. You've heard of seeding clouds. This is something they do in a regular basis. In China, when I was there in 2008, right before the Olympics, they used sodium iodide to seed the clouds to get the moisture out of the air so there would be blue skies everywhere. And the way they do it is they take silver iodide cartridges, they shoot them into the sky, and the sodium iodide crystals absorb water, hold the water droplets on, which allows precipitation to form, which then becomes a raindrop. So it's kind of a cool use of this chemical. So anyways, how do we attack this? Well, we have the KSP, and now we're looking for the solubility. So let's first write out the equation for the dissolution of sodium iodide. So we've got our sodium iodide solid, and that's going to form an aqueous silver plus 1 ion plus an aqueous iodide ion, right? And so the KSP, the equilibrium equation, it looks like this. KSP is equal to the concentration of the silver ion times the concentration of the iodide ion, right? So we know this KSP value is 1.5 times 10 to the negative 16, so we're going to plug that in here. And we can tell that since it's a 1-to-1 ratio of silver to iodine, that the amounts of each of these will be exactly the same. So this is X, this is also X. They're the same thing. So what I can do here is I can say this becomes X squared, X times X. So now all we have to do is solve for x. So we take the square root of both sides. So square root of 1.5 times 10 to the negative 16th, and that gives me the solubility of AgI, which comes out to 1.2 times 10 to the negative 8 moles per liter. Okay, so those two types of problems that you'll see with using the KSP or the equilibrium constant. As always, if you have questions, let me know, and copper tomorrow.